Okay, so this one here, to solve this, we're going to expand out the brackets because we want to see what all the different pieces that we're dealing with is. So we end up with 6x minus 10 plus 6 equals 2x's minus 4. Combine our like terms, and we end up with this expression. Now it looks like the 4's cancel out. So that means then that if I subtract 2x from both sides, I get 4x equals 0. And that means x is equal to 0. Now that being a strange result, I just want to check it. And I can always check it by plugging it back in. So I go 3 times 0 is 0. So 2 times negative 5 is negative 10. Plus 6 is negative 4. 0 minus 4 is negative 4. That all works out. For this next one here, we probably want to get rid of that divide by 5 first. So I'm going to times everything by 5. And we end up with 4x minus 4 squared. We have to remember times that 10 by 5. And we also have to remember to times that 15 by 5. Okay, so we're going to combine our like terms. We're going to subtract 50 from both sides. So to solve this, we basically want to undo this calculation. So I'm going to undo the plus with a minus. So I get 25. I'm going to undo this times with a divide. So the nice thing is I end up with a perfect square equals a perfect square. Now really I just need to undo that perfect square by square rooting. So I'm going to square root both sides. Now I have to be a little bit careful here because when I square root, the inside of that square could be positive or negative. So the answer to this has to account for the fact that it could be positive or negative. So we undo squares. We need to be careful about that. So I end up with x minus 4 is equal to plus minus 5 over 2. So that's going to give us x equals 4 plus minus 5 over 2. Okay, so the solution for x, I'm just going to write it up here. X is going to be 4 minus 2.5, which is 1.5 or 3 over 2. And then this is going to be 4 plus 2.5, so it's going to be 6.5. So we have a second solution, which is 13 over 2. So those are my two solutions, and I have to have two possibilities because that inside could be positive or negative, and we get the same result. For this one here, we're being asked to find the surface area. So for a surface area, we need to draw a net. Okay, so the net, I'm going to start at the bottom. So this is going to be my 13 by 20 bottom. I'm going to have the back edge here. This is my 8 by 20. And then I'm going to put my top edge here. I'm going to put my angled edge over here. And then I'm going to have my trapezoid. My two trapezoids on the ends here. Okay, so I need to work out the surface areas of each of these individual parts. I just want to make sure that I'm on the right surfaces here. So I'm just going to shade that one. And that's going to be my top surface. I just want to use that as a reference. I want to be able to keep track of this. So here, this top edge is going to be 7 by 20, so that's going to be 140 centimeters squared. This surface over here is going to be 8 by 20, so that's 160 centimeters squared. The bottom is a 13 by 20, so that's 260. The trapezoid is going to be the average of 7 plus 13, so that's 20 divided by 2, so that's my average length of the top and bottom, times by 8, and that's going to give me 80 centimeters squared here. Okay, and I can just do that by, making my 10 by 8 rectangle like that. Now this edge that I don't know, well, I know this edge is 20 here, and I need to work out this edge here. That's my unknown edge, and I'm going to have to use this right triangle here to work out that unknown edge. So this is my unknown edge here. Okay, so I want to work that out. And using Pythagoras, well, that's going to be 8. The horizontal 6. So 8 squared plus 6 squared equals 10 squared. That works out to be 10. So this area in here works out to be 200 centimeters squared. So when I add this all up, I get 300, 560, 760, 840, 920 centimeters squared. So my total surface area I'm calculating is 920 centimeters squared. Okay, that looks about right. Just make sure you double check your work when you do stuff like this.